This is the seventh in a series of video-based lessons that will introduce repetition, the third and final programming structure, by teaching you how to work with so-called do and for next loops. We will begin with do loops, covering both pre-test do while loop and post-test do loop until statements. We will then proceed with for next loops, arguably the simplest and most widely used repetition structure. We will conclude this video with some additional properties, methods, and events of list boxes and show how they directly relate to repetition structures. This material is covered in Chapter 6 of our textbook. We begin with do while loop, where the loop condition is checked first to see if it's true or false. If true, as in testing whether or not a number of customers is 5 or under, the first pass through the loop statement is initiated. A set of statements related to a particular customer are executed, and the number of customers processed is incremented by 1. Then the second check of the condition is made. If it still results in true, the second pass through the loop statement commences, and so on until we've processed our 5th customer. The counter variable becomes 6 and the loop condition evaluates to false. If the condition never evaluates to false, the loop would repeat endlessly and you would have to terminate the runaway execution. And this happens more often than you think. Also, if the condition is not true to begin with, if we started, for example, with 10th customer, none of the loop statements would ever execute. This too happens more often than you think as you're learning about repetition structure. A variation of the do while loop is to test the loop condition after the first pass through the loop has been made. That assures us that at least one pass will be made through the loop, and the condition for do until loop is typically a reversed one when compared to do while loop. You execute the statements within the loop until a condition becomes true, which assumes that it was false to begin with. We keep processing customers until we have finished with the 5th one, after which the condition becomes true and the loop terminates. Do loops overall are best used for situations where the condition depends on a user action, such as providing an input. As long as the user keeps providing input to the program that is doing something, like processing customer loans, the loop keeps churning. When user indicates that he or she is done, the loop, and typically the entire program, terminates. For next loops are used when a specific number of passes through the loop is known in advance. If we know we will be processing exactly 5 customers, the basic form of for next loop shown on this slide is the way to go. The counter variable, typically something like I or j, is initialized and incremented by 1 with each pass through the loop automatically. Once it hits the value of 5, that is the terminating value, the loop ends. Beyond the basic for next loops, this type of loop can proceed backwards with a -1 step, or use altogether different steps of 2 or 4 or whatever makes sense in a particular situation. Of course, do loops can do all this as well by carefully incrementing or decrementing the counter variable. In addition, nested loops of all kinds are possible. This works well for situations where for each pass through the outer loop, there has to exist another repetition structure performing a different set of tasks called an inner loop. For example, for each processed customer, we could decide to list the unprocessed ones. So, if we are currently processing customer number 2, that means I equals to 2, which makes the initial value of j for the inner loop equal to 3, I plus 1. And we would list customers 3, 4, and 5 as unprocessed. Then we return to the outer loop with I equal to 3, which would make the inner loop list customers 4 and 5 as unprocessed, and so on. Check out the graphics on the right side of the slide for all kinds of complicated nesting situations. Next, we review the few list box properties and events and then put them in the context of repetition structure. First is the count, returning the number of items on the list, starting with 0 and going to n minus 1, where n is the list box count. The second important property is the selected index. We already used it in our payment calculator application and LST rate list box. It returns a number between 0 and n minus 1 for the currently selected item, -1 if no items are selected, which is useful for testing if this is the case. The selected index changed event is triggered every time a selection is changed, including deselecting all the items. One of the most widely used properties is the items collection, returning an item in the ith position, which is often used when processing items on the list. Finally, when the list box sorted property is set to true, all the items are automatically displayed in alphabetic order.